So what are some possible solutions? As we said, x can be any number all the way up to -5, but not actually equaling -5. So we could get very, very close, such as -4.9, almost getting to -5, but not quite touching it. Also, any other negative number in between 0 and -5 would work. So -2, -1, 0. Okay. And then we can go all the way up into +5. So we could have a number like 1, 1.5, or 1.5. Any decimal, like 3.6, it doesn't matter. But in this case, 5 would be included as a possible solution, because 5 is in between -5 and 5, and the +5 is included. However, -5 is not. So those are just a couple examples of possible solutions of values you could plug in for x that would fit inside that inequality. Now, where we're going to be taking the inequalities now is into interval notation. So instead of using the less than or greater than symbols, we're going to be using either parenthesis or bracket to kind of denote a certain interval. So how this will always work is that when you have a less than or greater than symbol, these always will be using parentheses. Whereas if you have a less than or equal to or greater than or equal to, when it has the equal to bar underneath, then you're going to need to use the brackets. So brackets look like this. Parentheses, of course you know what parentheses are. Alright. And now when you have infinities, which we're going to look at here in a second, infinities will always use the parenthesis. Okay, something to keep in mind, something to note. So now actually graphing some of these inequalities. First example here. We want to write the inequality x is greater than -5 in interval notation, using either parentheses or brackets, and also graph it. So, how we write this in the interval notation, we have to think of, well, if x can be any number greater than -5, what is our low limit, what is our low end, and what is our high end limit? In other words, what's our minimum and maximum amounts we could have for possible values for x? So, low limit, comma, high limit. Or as I said, if you'd rather think of it as what is your minimum and what is your maximum. Okay. So if you think about it, x is greater than -5. That means x can be any number bigger than -5, but it can't be smaller than -5. And matter of fact, can't even touch -5. So the smallest value x can be is -5. And then there really is no limit. There is no maximum value it can be. It can be any number greater than -5. So that means it's going to go on forever towards infinity. If you look at like our number line, as you move to positives, you go towards positive infinity. So the minimum value it could be is -5, and because it is a greater than symbol, we use a parentheses. Infinity always gets a parenthesis, so we also put one around the right-hand side. And that's writing that same thing, x is greater than -5, only now in interval notation. So we have our minimum -5, our maximum infinity, and that's how you'd write interval notation. Graphing then would be using that same symbol and kind of drawing in the graph what were your possible values you could have for x. So we know the minimum value is -5, and we have a parenthesis around it here in our interval notation. We're going to draw a parenthesis at -5 here on our graph. And now x can be any number greater than that. So that's why I opened up the parenthesis to the right. All values to the right of -5 are indicating numbers that are greater than -5. So you'd fill in everything on the number line all the way to the right. And usually we then fill in the arrow indicating that it would go on forever towards infinity. So that's what the graph would look like. And maybe one more time just to put it in words, what does this actually mean? Well, it means x can be any number more than -5, but not actually equaling -5. Okay. So x can be any number more than -5, but not actually equaling -5. So now we're going to try to do the same thing with the next few examples. Okay. The next example, a little bit different. It's not a single inequality. It's kind of bounded inequality. It's got numbers on both sides. So remember, this just means that we have something, x can be any number in between two specific values, like we had up above here. So this is telling us that x is any number in between -1 and 3. The less than or equal to symbol means that it can equal -1. The strictly less than symbol here means that it cannot touch 3. It can get as close as possible to 3, but not actually be equal to 3. So let's first write this in the interval notation. The low end, what is the minimum value it can be? That's the -1, comma. What's the highest value it could be? Well, 3. Technically, it can't touch 3, but how do we indicate that? Less than symbol gets a parenthesis. Less than or equal to symbol gets a bracket. So this tells us the same thing that this does. Our x value can be any number all the way down to -1, including -1, and all the way up to 3, almost 3. Not quite 3, but right up as close as you can get to 3. So then go back to the graph. We have -1. Got a bracket there. +3, we have a parenthesis. And then everything in between is a possible value that we can use for x. So we have to fill in everything in between those two, -1 and 3. Okay. A couple more examples here, some special cases, and maybe not. Next example is that x is less than or equal to 1. Oh, here, before we do that, I like to write in here what does it mean. So this means that x can be any number from -1 to 3, including -1, but not 3. So we're including -1, but we're not including 3. Okay. So now let's move on to the next example. X is less than or equal to 1. So writing that in interval notation, what is our low end? Well, if x can be any number less than or equal to 1, it's going to go on forever down and towards the negatives. Here's -1, all the numbers less than that go to the left. If you're going forever, you're going to eventually, well, you approach negative infinity. So there is no, technically there's no minimum, which means we have negative infinity as our low end, which then tells us our highest that value x could be is that +1. Okay. And it is a less than or equal to symbol, which means we get the bracket because it has the equal to bar in the inequality symbol. So there's our interval notation. Writing this or graphing this would be a bracket at +1, and then x can be any number less than that or equal to it. So less than means we have to shade in everything to the left, including the arrow, meaning going on forever towards negative infinity. Last example on the page then. Oh, sorry, let me write this in again. So in words, this means x can be any number less than 1 and including 1. And that's what our interval notation and our graph indicates when you look at them. Last example, x can be any real number. Okay, well this means there is no restrictions. There is no low end limit. There is no high end limit. If you can go as small as possible, you're going to go to negative infinity. If you can get a number as big as possible, you're going to go to positive infinity. So that's exactly how we write our intervals. Our minimum, well, there is no minimum, so we write negative infinity. Maximum, there is none. It can go forever, so positive infinity. We write negative infinity to infinity inside parentheses. And then how that would look graphically? Well, the entire number line with both arrows should be shaded in. It can go on forever towards negative infinity on the low end, and then on the positive maximum high end, it's going to go on forever approaching positive infinity. When I describe why does infinity get parentheses rather than brackets, remember brackets tell you when x can be that specific number. Like x could be 1 in this situation, or up here x could be negative 1. But with infinity, you can never actually reach infinity. Infinity's forever. You know, any number you can think of, there's always going to be another number greater than that, and then a number greater than that. You never really can reach infinity, and for that reason, you're going to have the parentheses, not the brackets. Okay, you can never actually touch infinity. Just like a parenthesis up here means you're not actually touching the 3. You can get every number closer and closer to 3, like 2.99999, but not actually touching 3. Okay. In the next video, then, I will cover the next page of 3.1, which is actually solving these inequalities, doing some mathematical, really using some algebra. Okay.